Okay, 2.6 linear inequalities. So inequalities solve like equations with two differences. Inequalities, you have to worry about division by and multiplication by a negative. And inequalities are either graphed on a number line or we use an interval notation to answer them. Let me talk about the first exception there, or the first difference. So let's say I start with the number 5 and I know that 5 is greater than 2. Okay, I can add to this and I will still have a true statement. So if I add 3 on both sides, that's fair, right? The same on both sides, I get 8 is greater than 5. If I multiply by 2 on both sides, 16 is greater than 10. Okay, but where you have to watch out for is when you do this with a negative. So let's say I multiply by a negative 2 on both sides. I get a negative 32 and I get a negative 20 here. But because these are negatives, negative 20, so if I just kept this, I would then be saying that a negative 32 is greater than a negative 20, and that's not true. So to correct that, you would then switch the direction of the inequality. So this is correct. A negative 32 is less than a negative 20. So we switch the inequality sign to keep a true statement. Okay, so we're going to see that right away over here. So just as if this was an equation, if I subtract 2 on both sides, I get the negative 2x is less than or equal to a negative 3. And then to get rid of the negative 2, I would divide by negative 2. And that would get me x on this side. The negatives here cancel. But then because of what I just showed you, I do have to switch the inequality sign here. I would have to say x is greater than or equal to 3 over 2. Okay? So this is one way you can answer it. You can, so x greater than 3 over 2, you can graph it. And this is a very common way. So just put the number on a number line. You don't have to number it all the way from 0 to 1 and then 3 over 2 and then 2. Just put that number on there. And then this inequality sign says greater than or equal to. So because it says equal to, imagine that you have the number 3 over 2 in your hand. Okay, if I asked you, can you use 3 over 2? And you would hopefully then say yes, because it says greater than or equal to. So because you can use it, you can actually hold on to the number and grab it and squeeze it. So to me, that's like having an open hand, and squeezing it makes it closed. And greater than 3 over 2 means that it has to go to the right, because numbers greater than 3 over 2 are to the right. So this is the second way you can answer that question. And the third way would be to answer it this way, is with a set notation. So you could also say, well, square bracket, we'll talk about that a little bit more, but square means you are including a number, and then to the right. So there are 3 ways to answer this, with the inequality symbol, on a number line, and with brackets. Okay, we'll do another example here. So distribute. So 4q plus 3 is less than 2q plus 6. Subtract 2q on both sides. So we're trying to isolate q. So 4 minus 2 is, that's a q. That's 2q plus 3 is less than 6. Move the 3 over. So 2q is less than 3. And then divide by 2. So the answer ends up being q is less than 3 over 2. Okay, so let's look at some of the differences here. If this was an x, then it would say x less than 3 over 2. So how is that different from here? Well, I don't have the equal part underneath. So if I graph this on a number line, I start the same, so 3 over 2. Always start with a circle. Can you use 3 over 2? No, so you leave your hand open, leave the circle open. Less than 3 over 2 means that you need to point an arrow to the left. And then in set notation, if you cannot use the number 3 over 2, you would use a round bracket. Now, sometimes students answer it this way. So it's 3 over 2 and then to the left, so that means you go towards a negative infinity. And I would be okay with that, except I'm trying to show you what you probably are most likely going to see. So usually the answer would be written this way. So from a negative infinity out to 3 over 2. Okay? So the main difference between the solution of an equation and the solution of an inequality. If I told you that x equals 7 is the answer, so let's say maybe I was trying to work on, well, 2x is 14. Okay, well then x is 7 is the answer. And if this was an inequality, 2x is less than 14, I would get x is less than 7. Okay, so the main difference is that for the equation, This is, in this case, there's only one answer, so this is the only number, or it could be numbers, the only number that will produce a true statement. So only 7 will work. For the inequality, we don't have just one number that works. It says pick a number less than 7. So, 6 would work, right? 2 times 6 is 12, that's less than 14. 5 would work, 2 times 5 is 10, is less than 14, etc., 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 including all the decimals and the fractions and all that other stuff, and including negatives. So in an inequality, what it does is it gives you a range of numbers that will work. So often, and this is not always the case, but if the inequality does solve, generally speaking, we have infinite solutions, because there are infinite numbers to the left of 7. Okay? In terms of graphing and stating the interval, so open versus closed on the number line. So, and that probably should say open circle, closed circle. So I'm talking here about, do I use this circle or do I use this one? So open, if it's a less than or a greater than. Closed, if you use less than or equal and greater than or equal. Regular bracket versus the square bracket. Well, the regular brackets go with the less than and the greater than, and your square brackets go with the greater than or the less than and equal to. So keep in mind, regular brackets would be these, and when I say square brackets, I mean those. Okay, so x less than 5, that would be from negative infinity out to 5, but not including 5. X is less than or equal to 5, that would be from a negative infinity up to 5, including 5. On a number line, they start the same way. You graph a number 5 on the number line, it's to the left. Here it would be an open circle. Here it would be a closed circle. Alright, last part. So that should be most of the review. We do need to worry a little bit about compound inequalities. So the word compound usually means multiple. If you had a compound fracture, then you probably have a bone that's broken in at least 2 spots. And then there are 2 types of compound inequalities. It'd be great if you can recognize it. If you can't recognize it, then that's okay as well. You can solve it and recognize it after that. So, for example here, compound inequality. So it says 5 less than or equal to x plus 3 less than or equal to 8. Okay. What you have here really is you have 2 inequalities. You have this inequality. Move it. Oh. That doesn't work if I'm in the wrong layer. Okay, so if I look at it this way, so I have this inequality, x plus 3 is less than 8, that's one inequality. And the other inequality that I have is this inequality. And so I need to solve both of these inequalities, and that's what it means to have a compound inequality, is that you have 2 of them at the same time. So how would you do this? Well, I would do it as 2 inequalities. I would say, well, let's just solve x plus 3 is less than 8, and then I'm going to flip this one around, and then the other one would be x plus 3, and the x plus 3, the inequality opens, so you can flip the inequality symbol, so x plus 3 needs to be greater than or equal to 5, and then just solve both of the inequalities. So take away 3 on both sides, so x is less than 5, negative 3 here, and on this one you get x is greater than or equal to 2. Put it on a number line. 2 is smaller than 5, so it goes in this order. The 2 will get a filled in dot. This one will have an open circle. And then if it says less than 5, you would move it this way. And if it says greater than or equal to 2, you get an arrow that way. But because those arrows meet, you would generally just draw one line and you would graph it this way. So that is an AND inequality. So in an AND inequalities, your arrows meet. Okay, an AND inequality can be written as 1 one inequality. I'm sort of contradicting myself. What I mean with that is that it can be written all in a row like this. An OR inequality has to be given to you split. So if I give you an inequality like this, and you want to know if it's an AND or an OR, do you see the word OR? No? Well, then it has to be an AND. Okay. You can give an AND inequality this way. I could say x minus 7 is greater than 2 and x minus 7 is less than or equal to 11. So you can give an AND inequality with two separate statements. Alright, so the OR inequality, x plus 4 less than 5. So subtract 4 on both sides. I get x is less than 1, or 2x minus 1 is greater than 8. So that means 2x is greater than 9, so x is greater than 9 over 2. Put it on a number line. 1 is smaller than 9 over 2. This one has an open circle, and it says less than 1. This one has a closed circle. Also an open circle, and it goes to the right. And this is what should happen with an OR inequality, opposite directions. So OR goes with opposite directions. And what I just said is we have to have two statements. I guess I should have just used the word statements a moment ago. Okay? Alright, thank you.